Vietnam, 1967. A UH-1 Huey helicopter banks low over the jungle canopy, its rotors beating the thick air into submission. Below, a North Vietnamese platoon moves through the elephant grass, confident in the cover provided by the dense foliage. They never see the helicopter. They hear it for exactly 2 seconds. Then they hear something else. A sound unlike anything in the history of warfare. Not the crack of rifles, not the thump of artillery. Something that sounds like the universe itself being torn in half. A mechanical scream that delivers 100 rounds per second into a space the size of a dinner table. In those 2 seconds, 200 bullets, each one capable of punching through an engine block, shred the jungle into confetti. Trees disintegrate, the ground erupts, and when the sound stops, there is a silence so profound it feels like the world has forgotten how to make noise. The weapon that created this devastation weighed just 85 pounds. It had 6 barrels that spun so fast they blurred into a single metallic cylinder. It could empty a 4,000-round ammunition container in 40 seconds. It was never designed to kill individual soldiers. It was designed to eliminate the concept of cover entirely. The M134 Minigun was, and remains, the most fearsome suppressive weapon ever mounted on an aircraft. But its origins had nothing to do with helicopters, jungles, or Vietnam. They began in the mind of a 19th century inventor who wanted to solve a problem that had plagued armies since the invention of gunpowder. How do you shoot faster without melting your gun? The year is 1862. The American Civil War is tearing the country apart. A doctor and inventor named Richard Gatling watches the casualty lists grow longer and has what seems like a paradoxical thought. What if he could invent a weapon so deadly that wars would become unthinkable? History would prove him catastrophically wrong about that philosophy, but his mechanical solution was brilliant. The problem with rapid-fire weapons was simple. Continuous firing heated the barrel to the point of failure. Metal expanded, rounds jammed, barrels warped. Fire too fast for too long, and your weapon became a useless lump of overheated steel. Gatling's solution was elegant. Don't use one barrel, use many. Arrange them in a circle. Rotate them continuously. While one barrel fires, the others cool. Each barrel gets a rest period. The weapon as a whole never stops shooting. The original Gatling gun used a hand crank and could fire approximately 200 rounds per minute, revolutionary for its time. By the 1890s, electric motor-driven versions pushed this to 3,000 rounds per minute. But then, something curious happened. The Gatling gun disappeared. The early 20th century belonged to different technologies. The Maxim gun and its descendants used recoil operation. The energy from firing one round automatically chambered the next. These weapons were simpler, lighter, cheaper. By World War I, the Gatling principle seemed like a mechanical dead end, a Victorian curiosity made obsolete by more elegant engineering. It would take jet engines and the Cold War to prove everyone wrong. The problem facing the U.S. Air Force in the 1950s was one of velocity and physics. Fighter jets were now flying at speeds approaching Mach 2. Engagement windows, the brief moments when an enemy aircraft was within firing range, had shrunk from minutes to seconds. A pilot might have 3 seconds to get rounds on target, maybe less. The standard aircraft gun of the era was the M39 cannon, a 20mm revolver cannon that fired approximately 1,500 rounds per minute. Effective for its time, but the math was unforgiving. At 1,500 rounds per minute, that's 25 rounds per second. In a 3-second engagement, you're putting 75 rounds into the air.
against a target moving at 600 miles per hour, crossing your flight path at angles that make trigonometry weep. 75 rounds was marginal at best. What the Air Force needed was a weapon that could put 6,000 rounds per minute into the sky, 100 rounds per second. A weapon that could turn a 3-second engagement into a wall of 300 bullets. A weapon that could compensate for the impossible geometry of supersonic combat by sheer volume of fire. The contract went to General Electric's Armament Division in Burlington, Vermont. The year was 1956. The design team went back to first principles and rediscovered what Richard Gatling had known a century earlier. If you want to fire faster, you need multiple barrels. But 1950s materials science and electric motor technology could do things Gatling never dreamed of. The GE team designed a 6-barrel weapon where each barrel completed a full cycle: chamber, fire, extract, eject, with every rotation. The barrels were driven not by a hand crank, but by an electric motor capable of spinning the entire assembly at 6,000 RPM. The prototype was designated the M61 Vulcan. It fired 20mm cannon rounds at 6,000 rounds per minute. It was a revelation. The Air Force immediately ordered it into production for the F-104 starfighter. But General Electric's engineers saw something else. If the Gatling principle could be scaled up to 20 millimeters, it could also be scaled down. The M61 Vulcan fired a 20-millimeter round weighing approximately 100 grams, devastating against aircraft, complete overkill against human targets. What if you took the same rotating barrel system and chambered it for the standard 7.62 by 51 millimeter NATO round, the same ammunition used in the M14 rifle and M60 machine gun? The result was designated the M134. The nickname Minigun was almost a joke. It was only mini compared to the Vulcan. At 85 pounds empty, it was heavier than any weapon an infantryman could carry. But for a helicopter, 85 pounds was nothing. And for a helicopter operating in Vietnam, the M134 was about to become essential to survival. The specifications were extraordinary. Rate of fire, 2,000 to 6,000 rounds per minute, variable. 6 barrels, each 22 inches long. Overall length, 31.5 inches. Muzzle velocity, 2,800 feet per second. Effective range, 1,000 meters. But raw numbers don't capture what made the M134 revolutionary. To understand that, you need to understand what it was like to fly a helicopter in Vietnam.
Helicopters in Vietnam faced a tactical nightmare. They were slow, maximum speed around 120 knots. They were loud, audible from miles away. They were vulnerable, thin aluminum skin that rifle rounds punched through like cardboard. And they operated in an environment where the enemy controlled the ground and had unlimited places to hide. A typical helicopter assault insertion went like this. Intelligence identifies a landing zone. The helicopter approaches at altitude to avoid ground fire. As it descends, it becomes increasingly vulnerable. At 100 feet, small arms fire becomes effective. At 50 feet, even poorly trained soldiers can hit a hovering helicopter. The most dangerous moment is touchdown, when the helicopter is stationary, troops are disembarking, and every North Vietnamese soldier within 500 meters is shooting at a target that cannot maneuver. The standard defensive armament was the M60 machine gun, a 7.62 millimeter weapon firing approximately 550 rounds per minute. Good for suppressing individual positions, inadequate for suppressing an entire tree line. Door gunners did heroic work with M60s, but they were trying to fight area targets with a point weapon. The M134 changed the equation entirely. Mounted on a pintle in the helicopter door, it could be aimed across a 180-degree arc. At 4,000 rounds per minute, it delivered 66 rounds per second.
The weapon didn't suppress enemy fire, it erased the positions from which that fire was coming. The first operational deployment was 1963. Early models were plagued with mechanical issues, jamming, feeding problems, motor failures. The mechanism was asking something extraordinary of 1960s engineering. Spin 6 barrels at 100 revolutions per second. Chamber and fire 100 rounds per second from a flexible belt feed. Maintain precise timing across 6 independent firing cycles. And do all of this in tropical humidity, dust, vibration, and the chaos of combat. But by 1965, the bugs were worked out. The improved model was designated the M134A1, and it became standard equipment on UH-1 Hueys and AH-1 Cobra attack helicopters. The tactical effect was immediate. Landing zones that had been death traps became survivable. Helicopter crews that had been flying into walls of ground fire could now preemptively destroy anything that might shoot at them. The sound alone was psychological warfare. NVA soldiers who had learned to ignore the sound of M60 fire, a familiar, predictable staccato, found the minigun's mechanical shriek genuinely terrifying. What does 6,000 rounds per minute sound like? It doesn't sound like gunfire. Individual shots merge into a continuous tone, a mechanical scream that oscillates between a buzzsaw and a dragon's roar. The closest comparison is an industrial shredder, but louder, and with the knowledge that what's being shredded is the landscape itself. The sound is distinctive enough that veterans can identify it instantly decades later. It appears in countless Vietnam War films, though the recordings never quite capture the visceral impact. The way the sound travels through your chest cavity, the way it seems to distort the air itself. The visual signature is equally distinctive. 6 barrels spinning at thousands of RPM create a blur. Muzzle flash from 6 guns firing in sequence produces not individual flashes, but a continuous ring of fire. Spent brass pours from the ejection port in a glittering stream, hundreds of cases per second clattering against the helicopter floor. And the effect on target is catastrophic. A single 7.62 by 51 millimeter NATO round carries approximately 3,600 joules of energy. At 100 rounds per second, the M134 delivers 360,000 joules per second to the target area, 360 kilowatts of kinetic energy. For comparison, that's roughly equivalent to the power output of a Formula One race car engine, except instead of turning wheels, it's being dumped into whatever the gun is pointed at. At 100 rounds per second, the M134 doesn't create bullet holes, it creates destruction on a scale that's difficult to process. Wood doesn't splinter, it disintegrates. Vegetation doesn't get damaged, it gets pulverized. Trees don't fall, they explode into fragments. The weapon doesn't aim at individuals, it eliminates areas. The heart of the system is the rotor assembly. 6 barrels are arranged in a circle around a central camshaft. An electric motor, originally 115-volt DC, later upgraded to 28-volt DC, drives the rotor through a reduction gear system. As the assembly rotates, each barrel moves through a complete firing cycle. At the 12 o'clock position, a new round is chambered. At approximately 2 o'clock, the bolt locks. At 3 o'clock, the firing pin strikes. At 6 o'clock, the bolt unlocks. At 9 o'clock, extraction occurs. At 11 o'clock, the spent case is ejected and the cycle begins again. This rotation means each barrel fires once per revolution. At 6,000 RPM, the rotor completes 100 revolutions per second, delivering 600 rounds per barrel per minute, or 6,000 rounds total. But here's the elegant part. Because firing is distributed across 6 barrels, each individual barrel only fires at the rate of a standard machine gun. Each barrel has time to cool. Barrel life is extended dramatically compared to a single-barrel weapon firing at equivalent rates. The ammunition feed system is its own engineering challenge. At 100 rounds per second, the weapon consumes ammunition faster than most machine guns empty their entire belts. The standard feed is a linked belt drawing from ammunition containers holding 3,000 to 4,000 rounds. The feed mechanism must strip rounds from the belt, align them for chambering, and do so 100 times per second without jamming. The power requirements are substantial. The electric motor draws approximately 4 kilowatts, roughly the same as an electric oven, with peak draw during spin-up even higher. Helicopter electrical systems had to be upgraded to handle the load. To understand the M134's significance, consider what else was available in the 1960s. The M60 machine gun fired 550 rounds per minute, effective rate with barrel changes and reload, perhaps 150 rounds per minute sustained. Man-portable, versatile, reliable, but firing 2.5 rounds per second. The Browning M2.50 caliber fired 500 rounds per minute. Each round carried far more energy than the 7.62 millimeter, capable of destroying light vehicles and penetrating cover, but still firing 8 rounds per second at best. The M61 Vulcan, the minigun's big brother, fired 6,000 rounds per minute of 20 millimeter ammunition, devastating against aircraft and armored targets, but weighing over 250 pounds and requiring substantial mounting systems. The M134 occupied a unique niche. It delivered the rate of fire of the Vulcan with ammunition that was cheaper, lighter, and available in vast quantities. It couldn't destroy vehicles like the .50 caliber, but it could put 10 times as many rounds on target. It wasn't man-portable like the M60, but from a helicopter mount, portability was irrelevant. The Soviet answer came in the form of the GSHG 7.62, a 4-barrel Gatling-type weapon introduced in the 1970s. It fired at rates up to 6,000 rounds per minute, similar performance to the M134, but it never achieved the widespread adoption of the American weapon, which became the standard by which all others were measured.
Vietnam ended in 1975, but the M134 didn't retire. It found new roles across military aviation and special operations. In modern combat helicopters, the M134 remains standard equipment. The MH-60 Black Hawk commonly mounts them as defensive armament. The MH-47 Chinook uses them for door defense. Special operations variants of the Little Bird mount them as primary offensive weapons. The AC-130 gunship, essentially a flying artillery platform, mounts M134s as its lightest defensive armament, complementing heavier weapons like the 40mm Bofors cannon and 105mm howitzer. The most significant modern development is the Dillon Aero M134D, introduced in the 2000s. This version addresses many limitations of the original design. Improved feed system reduces jamming. Titanium housing reduces weight to 62 pounds. Better rate control allows precise adjustment from 3,000 to 4,000 RPM. Enhanced reliability. Mean rounds between failure exceeds 100,000. Modular design simplifies maintenance and barrel changes. From the jungles of Vietnam to the mountains of Afghanistan, from the Mekong Delta to the streets of Mogadishu, the distinctive sound of the minigun has meant survival for American forces in desperate situations. But the M134 is not perfect. At 6,000 rounds per minute, the weapon empties a standard 3,000-round container in 30 seconds. Helicopter payload is finite. Carrying ammunition for the minigun means carrying less of something else: fuel, personnel, other weapons. The logistical tail is substantial. The weapon also requires meticulous maintenance. Barrels must be inspected for wear. The feed system must be cleaned and lubricated. Electrical connections must be checked. Timing must be verified. The weapon doesn't fail gracefully. A timing error might mean a round fires out of battery, potentially destroying the weapon and endangering the crew. And there's the philosophical question.
Using a weapon that fires 100 rounds per second against individual targets raises questions about proportionality. Military doctrine addresses this through rules of engagement, but the uncomfortable reality remains. The M134 represents overwhelming firepower as a substitute for precision. The practical reality in modern conflicts is that the M134 has proven itself indispensable in specific roles. For helicopter defense during insertion and extraction, nothing else provides equivalent suppression. For special operations when overwhelming firepower in a brief window is required, the minigun remains unmatched. Nearly 70 years after its development, the M134 remains in frontline service. This longevity is remarkable in military aviation, where most systems are replaced within decades. The reason is simple: nothing better has emerged. Various alternatives have been proposed. Electrically driven chain guns offer some advantages in weight and reliability. Conventional belt-fed machine guns continue to improve. But when the requirement is maximum rounds on target in minimum time, the Gatling principle remains unbeaten. The M134's real legacy might be philosophical rather than technical. It proved that the Gatling principle, written off as obsolete in 1900, was simply waiting for the right application. It demonstrated that sometimes the old solutions are the best solutions, just waiting for technology to catch up. And it established that in certain tactical situations, there is no substitute for overwhelming firepower delivered with absolute reliability. Richard Gatling's dream of a weapon so terrible it would end war was naive, but his engineering principle, multiple barrels, continuous rotation, distributed heat, proved to be one of the most enduring concepts in weapons design. The M134 is his legacy, refined by modern technology into the most effective suppressive weapon ever mounted on an aircraft. And somewhere, right now, in a jungle or desert or mountain range, a helicopter is banking into a landing zone. In its door, an M134 is spinning up, barrels beginning to blur, the mechanical scream building. And for the next few seconds, 100 rounds per second are going to remind everyone in the area why helicopters don't land unopposed. If you found this deep dive into weapons engineering fascinating, a quick subscribe helps more than you know.